So today we'll be doing conditionals, if this then that. We'll be doing loops, so while loops, for loops, and we might get into what are they called? They're not generators. I forgot the name, and I was just reviewing this like an hour ago. Square brackets and loop inside the square bracket. I can't remember the name of it, but we'll be doing that. Yeah, list comprehension. Thank you. And but first, we're going to review collections, because that's going to be pretty critical to all of this stuff, and that's what we did last week. And repetition is memorization. So, can someone tell me how to write a list? Let's say I want to create a list of numbers from 0 to 3. I want to store them in X. What would I type?
X.
Mm-hmm. Yep. Cool. What if I wanted to do a dictionary?
Key and value.
Yep. Well, whoops. There's something missing. Everything has to agree. What if I want to see what the value stored at other key is?
X. Square bracket.
Mm-hmm. There we go. I don't remember if we covered this last time, but you can get the keys by dictionaries have this function called keys, and it will spit out a dict keys of keys. You can convert that to a list. Same for values. So no rocket science there, pretty simple stuff. Does anyone remember what a tuple is? Yep.
Immutable.
Does anyone remember what immutable means? Not someone in the front row.
Unchangeable.
Yes, both of you are correct. So if I can grab the second value, but I can't set it. It's like you can't do that. Okay. So that's pretty much a review of last time. There is one more collection type that I want to tell you guys about. It was in the very last bit of chapter 3. It's called a set. Sets are a collection like a list or a tuple, in that they store a series of values, but they only allow one instance of each value, and they look kind of like a hybrid between a dictionary and a list. So if I want a set, I do something like this, and that is a set. So if I check the type of X, it's going to tell me that it's a set. Can you guys see? That's a little low, huh? Let's do something like this. Well, if I could click properly, you would never guess that I play video games. Let's also redo this. Beautiful. Alright, can you guys see that? Is that a little clearer? Easier to see for those in the back? Cool. And the nice part about sets is if you ever need to compare values between two collections, like let's say I want to find values that are shared among two sets. Alright, so let's say I have another set. If I could type, let's say I have 4, 6, 9, right? So X is this, why is that? And now I have to remember the syntax because I've actually never used sets before this class. And you could do something like, where is it? Where is it? There's a way to combine them. Oh, that's right. You can use an ampersand. So an ampersand means and, kind of a logical and. So you can say, what's in x and y? In this case, x and y only store 6, or only share 6. So when you run them together with the ampersand, you get 6. Really nice part is that if you, let's say you have a, and this is just wonderful little, wonderful little Python things. So let's say I have a list of a whole bunch of values, right? Is that actually valid? Sweet. I can convert it to a set, right? You'll notice that it gets rid of the duplicate value. So that's really useful. And then if I had another thing of, I don't know, something like that, you could do the same thing, and then you could always do, and there we go. No matter how many duplicate values there are, all that sort of stuff, it just makes life a lot easier. So you can switch between the different collection types really easily and quickly. Something funky with set, if you, so we all know a string, right? This is a string, right? If you do, this is a string as a set. So if you want to find all the unique characters instead of text, strings, when converted to sets, it splits them into their individual characters. And then, again, because sets only allow one of each instance, they get rid of the duplicates.
Why is it in order?
I don't think order is guaranteed in a set. I think that's a byproduct of the fact that it's eliminating duplicates. So it's doing all sorts of crazy math that's smarter than me. Does that answer your question? Cool. It's not really a good answer, but it just does. New to me too. So, and then there's also, we haven't learned that yet, and I'm doing that slightly out of order because, yeah, because I want to do lists all together, or not lists. Yeah, so that's pretty much it. Do sets? Oh, you can also do differences. So you can say, let's just do this. Okay, so now we have 2 sets. What if I wanted all of the values that are in x but not y? You could do x minus y. So that's super, super useful. You can do it the same. You can do like one set, another set, it doesn't matter. So in this case, x minus y. So the only values that are not in y are 1, 5, and 9. So when you take the set of x and you remove the values that are in y, those are the ones left over. So that's why that works. I think, can you do an OR? I don't think you can. Oh, you can. And then that effectively combines the 2 sets. So if a value is in either x or y, it'll return the combination of them. I was a little bit confused.
What if you add?
Oh, what if you add? I don't know. Just find out. Again, they're new to me. Yeah, so it doesn't like that. It's probably because of crazy Boolean logic. It would prefer that you use an OR. Yeah, no. It would make sense that adding would operate like a pipe. Pipe is an OR. But I guess not. Python people are arbitrary. So yeah, if you think you want to add, you actually want to use a pipe. In most programming languages, a pipe means OR. To be absolutely clear, a pipe is shift backslash. If you look on your keyboard, it's right here. If you do shift this key, oh, this one, oh my god. Get the idea? Experienced programmers will be like, I know what a pipe is, come on. And then an ampersand is usually and. So, whoa. I hate idle so much. So there's that.
Say pipe.
Pipe. P-I-P-E. The reason, one of the reasons why it's called a pipe, if you look at Linux shells in our systems guide, this might make you happy. When you run commands in Linux, they produce some sort of output, right? Just like a function in Python or any other programming language. And you can pipe that output as an input to something else. So that happens in systems, and that's the symbol that you use, so it just started being called pipe. It might have some other name, but I don't know what it is. That's what everyone I know calls it. So, any other questions before we call Chapter 3 closed and finally move on to Chapter 4? Cool. So we have a new person. Welcome.
Hi.
Feel free to follow along on your laptop if you have one. If you don't, you can feel free to sit next to someone and kind of see how they're doing. We're going along a book that we have posted in the Kakao chat and the Slack channel. If you're not on either of those, afterwards I can help you get set up. And we just finished Chapter 3 of the book. We were just reviewing and adding one more thing, and now we're going to start on Chapter 4. So yeah, if you don't have a machine, you get the chance to make new friends. Oh, and just like any of the other data structures that we've been learning, you can combine all of these collection styles. So you can say, like, I want a dictionary that stores a set, and then I want another value, or let's say that has a list, and that things like this work. They're kind of silly, but like that all just works. So nothing new there. You combine these as you see fit. In Python, the type doesn't matter, so you can combine strings with lists, integers with sets. It doesn't care. Python is very easy like that. Cool. So and we're good. Chapter 3, no questions. Sweet. Let's do Chapter 4. This is where programming starts to get a lot more useful. What we've been doing is kind of like super foundational stuff. What we're doing next is still kind of foundational stuff, but much more useful. This is where you use actual logic. So in Python, or in most languages, there's the construct of if-then. If some expression is true, then execute some logic. Otherwise, move on or run some different logic or whatever. So in Python, like most languages, it maintains use of the keyword if. And then you can say if true, whoops, because Python, capital T. And then true can be any expression that evaluates to true. When it comes to numbers, any number that's not 0 is considered true. Right? You can also do like 0 less than 10. That also evaluates to true. I think it's 0, false, and I want to say none. We'll test in a second. Are all evaluated to false, and then everything else is true. So we can say if true, and you'll notice that after I hit enter there, Python knows based on this colon. Okay, it knows that we're going to have kind of the colon is the then, if you will. So then you'll notice here that there's an indentation. This is very important, and we ran into this either last time or the time before. Indentation in Python matters a lot. So make sure you're using a good editor that you can see how much space is in between, because if you have your indentation wrong, you're going to spend hours trying to find where you're missing one little space, and that sucks. So we can say and then Python will assume that you're continuing in the loop, but if you just hit that, it'll go. And as mentioned before, other values can be used for true. And there are certain things that are not true. Now you'll notice nothing was printed because it's not going to run what's then if the if is false. Does this make sense so far? Is anyone totally confused?
It doesn't know what none is, right?
None evaluates to false.
Oh, is it? Okay.
Yeah.
Why didn't it print anything?
Because it only prints what's here if this expression is true.
Okay, but they have nothing to base that on, right? Is that what you're saying? Like,
Because
false.
right.
Yeah, it's like you have nothing to compare with, right?
Yeah. No. So none is within a condition.
Okay, that's always false.
Yes.
Okay,
Yes. But you can also do comparisons. So you can say 10 greater than 5. Right? But if I were to do that prints nothing. Because 10 less than 5 is false. Okay. All good? Cool. So there are other things we can do. So an if is just part of the construct. You can also do else. So we can say if false, print false is true, right? And so because false is not true, that will never print. And then you can say else. Ooh, do you not like, what? Sorry, this is idle silliness. This is why I hate idle so much. No? I guess.
Oh, yeah.
Yeah.
That's right.
Okay. So to get out of the indentation, you use backspace. I hate idle.
But can you explain again why it's not printing? Because you're saying if it's false and it is false, it should print that, right?
So think of so the way that it needs to be looked at, you have the keyword if, and you have the colon.
So if we do if exclamation false, then it's going to print.
Correct. So whatever's between the if and the colon must evaluate to true,
Okay, gotcha.
and then it will run.
Oh, that's the same.
Nope.
Yeah, that's the same as other. I'm just kind of confused.
No, it's all good. Covering super basic stuff is like, oh yeah, that's how it works.
So basic, yeah.
Yeah.
Just like we all know that.
So what he was mentioning is there is a way to invert a statement. So you can do, oh geez, I hope this isn't. You can do, crap. Is exclamation? It's either exclamation or tilde. I don't remember. Let's try it. Whoops. Oh no. Okay, so it must be tilde. No. That's right. Python has the keyword not to do the inverse of value. So you can say if not false. Not false is true. And be aware, in case you haven't figured it out already, the hard way, case matters. False must have a capital F. Not must be all lowercase. These sorts of things. So you can also say if not 10 greater than 5. Same thing. Okay. On that note, there are other operators. So, our other comparison operators when it comes to arithmetic. You can do 10 greater than or equal to 5. Wow, get wrecked. Okay. And this is a gotcha. This is very tricky. This is not what you think it is. In most programming languages, equals only means assignment. Okay, so what it's going to do is it's going to try to set 10. It's going to assign 10 as 5, which doesn't work. You want to do double equals. Double equals is compare. Is 10 equivalent to 5? And obviously that's not going to print anything. So that's something to be aware of that will bite you if you're not careful. Because I believe, if I remember correctly, I know this is true of PHP, but I forget Python. Assignment evaluates to true, I think. No. The value, the if condition looks at the value being assigned. So let's make sure I'm not a liar. So if I do this, oh, it doesn't even let you do that. So there we go. So if you see that, you want to do double equals because you're trying to do comparison. I do like Python more than PHP. So back to other if constructs. So you can do 10, if 10 less than 5, that's not true. And then you can say else print 10 is not less than 5. Okay, so that's else. Now there's something else we can do, or whatever is in else will execute if its if condition is not true. So if this is false and this doesn't run, only then will this run. Okay? Pretty simple, but you need to cover it. And then we have another construct. Elif, because Python has to be difficult, which means else if. Elif means that if none of the previous conditions within this block are true, and this condition is true, then run. Okay? We could do right? So both this must not be true and this must be true in order for this block to run. Any questions? Kind of basic. Cool. All right, now let's get to more fun stuff. So those are conditions. Pretty simple. Python doesn't have switch case, right? No, it doesn't. So let's move on to loops. Usually loops and conditions are taught together because loops rely on conditions. Oftentimes. Python has some funkiness to it, but whatever. So in many languages they have a construct called while. And while has some condition, and don't actually run this. Don't actually run this. Where if this condition evaluates to true, it will run the following logic until that condition is no longer true. So we can say and that will never stop running. But this is a good tip. If you're running anything on command line, including in the idle shell, Control-C, and I think that's true on Macs as well, will force quit. It sends a sig term if you're familiar with system stuff. So yeah, there's that. You can also, so what a lot of people will do, or another way to write a while loop that might terminate, you could say, let's set x to 0, right? And you can say, while x is less than, let's say, 10. Oh, sorry, you don't need parentheses, this is Python. Print x is, and then you can say x equals x plus 1, which there's a shortcut for that, which we'll cover in a second. Oh, really? Oh, screw you, Python. Being finicky. string x, because it only wants a string. So x started as 0. We set x to 0 at the very beginning. And then the while loop runs, and it goes, okay, cool, what's x? X is currently 0. 0 is less than 10? Cool, I'm going to run. Then it runs what's in here. So it prints x is 0. Then it increases x by 1. And it goes back and then it goes back to the beginning condition. What's x? X is 1, cool. Is 1 less than 10? Yes, let's run. Okay, pretty simple stuff. And this is going to sound pretty basic, but just to, so then we could set a variable like should run. We can set it to true, right? We could say while should run. Well, and this is just another way of saying the same thing. Say print should I run, or let's just print I am running. And then we can say x greater, if x is greater than 5, then should run equals false. And then otherwise x equals x minus 1.
Oh.
Hmm?
You should set x first.
X is already set. X is still 9. We haven't changed it.
Okay, great.
Okay. What's going to happen here?
You go on forever. No.
Oh,
It'll never.
I did that backwards. You're right. It'll run once. So this way it'll run once. Because should run is initially set to true. Should run is initially set to true, so it passes the condition the first time. Then it does its stuff. X is greater than 5, so it sets should run to false. Reduces x by 1, and then let's also just show that. Oh. Interesting. But yeah.
It should be that x equals x minus 1. Oh, never mind.
X was 10. Oh, right.
Oh, you're right. Because it does it at the very end.
Right.
Yeah, if I had done these in different order, it would have. Yes, thank you. So now if we do less than 5, what will this do? Now that I do what I intended to do. If x is currently 9, what will happen?
You gotta set should run first.
Oh, thank you.
Should we run 6 times?
9, 8, 7, 6. Yeah. So it's going to run 9, 8, 7, 6, and then on 5, it's going to print and then say, I'm not going to run after this. And then it decreases x. There you go. So what is x? Why is x 3?
Oh, yeah.
Oh, because it has to be less than 5, not less than or equal to. So it gets set to 4, and then it runs, and then it becomes 3. Questions? Simple loops are confusing, right?
You made it confusing.
You're right. But this is like, yes. The first example was much easier. So that's the while loop. There's also in Python the for loop. But for loops are often used in collections. So let's say I had, let's just make a tuple, 1, 2, 3, 4, 10, 20, 30, 40. Okay, so we have this tuple. In other languages, you can do like from number to number. Python can do that too, but Python lends itself better to working with collections. So you can say for let's call it my num in x. So what this will do is it will pull each value out of x one at a time and set it equal to my num. And then it's going to print it. Super basic stuff.
Is my num my number?
Yeah, that's just what I called it. You could call it whatever you want. It's just a variable. So I could also say monkey. I'm just gonna do this. Except I still called it my num in the text, but whatever. The variable doesn't matter. Oh,
You gotta change my num.
you're right. Thank you. Let's just do this. There we go. Doesn't matter. It's just a variable name. And this works with any sort of collection. So we did it with a tuple. Yeah, we can also do it with lists. Let's just stay there. Let's just no. There we go. Same thing. You can also do it with dictionaries, but it may not do what you expect it to do. What do you expect this to print out? Bernard, don't answer, because I know you know this. It's confusing, right? There's not any sort of kind of you can't know just by looking at it what it's going to print, which is something I like about Python. But this will print the keys. So that's something to be aware of. However, actually, let's see how good my memory is. Forget if you have to do you have to do iter items for this or no? I don't remember. Okay.
Yeah.
Oops. Huh? Huh? Oh, print I, thank you. Thank you, thank you. But wait, no, because it's still complaining at the value error. So I believe you have to do... Whoops. Really? Oh, that's right, they changed it in Python 3. Ugh. Keep doing that. There we go. If you want the keys and the values, dictionaries have a method called items, which will give you keys and values. Okay? And it allows you to iterate through both of them. Okay? There's other nifty tricks. Remember earlier if we have a list like this, right? This will print out the value, or each of the values, right? However, wait, whoops, did that wrong. Sorry guys. You don't want X, you want the value. There we go. Okay. What if you wanted not only the value, but the position of the value, the index of the value? Remember earlier, if we want, how do we access the third item in here? Right? What if we want both 2 and 6? We can do similar to dictionaries, where in dictionaries you have keys and values. In lists and tuples, you have indexes and values. So enumerate is how you pull out your indices, whatever you ask. Questions so far? Yes, no, maybe? Yeah, so this is a double parentheses because we're ending the string conversion and then we're ending the print. So that is...
So index and value, they're variables you're setting when you're doing for, right?
Correct. So what happens is when we run enumerate x, it's going to, in Python we call it unpacking, where we unpack two values out of the enumerate function. It basically returns two outputs. Here's something cool you can do too. So let's say I have, just to be a little clearer, I'm going to have a tuple of lists. Okay? Oops. Whoops. There we go. So we have a tuple that has 3 lists, and each list has 2 values. Okay? In Python, I should really be using strings just so that I don't have to keep doing string conversion. Because each item within X has 2 values, the for loop will properly unpack them. You can do this with 3, with 4, with however many. Okay?
They don't do that in like C++.
Nope.
Yeah, that's Python.
Fancy, fancy stuff. I think Go does it too. I haven't written Go in like 6 months now. But yeah, that is something that Python is like, makes life really easy for. But what if you just wanted to count from like 1 to 10, right? There's this range function. Range is super useful. If you give it just a single value, it will go from 0 up until that value, but not including it. So in this case, we get 0 through 9. In other programming languages, this is kind of more typical of what you would expect them to do. Actually, can someone close the door? We just don't have so much noise. Thank you. You can also feed range 2 values. So let's say I wanted to go from 5 to 10. Let's just copy this. I don't want to have to write this 50 times. You can do that. Let's say we wanted to do, oops. All right, we can do that too. No big deal. But another cool thing is range permits steps. So let's say I wanted every other value from 5 to 10, or 5 to 20. Oops. What is this going to print out?
5.
Yes. Can also go backwards, and this is going to make me look like an idiot, but we're going to try it. I think you can do something like this. You can count backwards too. You just have a negative step. So that's super useful.
So that last number before the parentheses, that's setting the condition, like how many to skip.
Yeah. So this is your start, this is your stop, and this is your step. So we're taking a step of -1. We're starting at 20, We're stopping at 5. Yeah. What if we did, I don't actually know what's going to happen here, so let's check this out. What if we do, because that will never stop, right? I really hope Python yells at us. Nope. It realizes that it can't count by -1 to get from 20 to 30, so it just doesn't give you anything. So that's a nice kind of making sure you're safe. So that's range. We covered that. We covered collections. We covered...
Sorry, can you just scroll up a little bit more?
Yeah, sure.
Okay, that's good. Alright.
Oh, that's right. I don't know why they tossed this in here. This is less useful when we're working in idle, but when you start writing your own Python programs, this will be very, very, very useful. You can make lines of code not run, or you can put anything in there, really. It doesn't have to be code. They're called comments, because the intent is that you add comments to your code so that when other people look at your code, they understand what's going on. So I can say, this is not valid Python code. And because it has this hashtag in front of it, it doesn't run. Python just ignores it. So that's a thing. Python doesn't really have multi-line comments. That's not so much a thing. So you have to do a hash for each one. However, Python does provide line continuation. So if we want to do this, you can do a backslash. A backslash is escape, or pretty much treat the next character literally. So a new line is treated literally. Let's also do something like this. And we don't need 2 pluses, because that's just confusing. So you can continue lines with backslashes, which is really useful if you have like a really, really long body of text. So you can do something like, and that just makes things a little cleaner so you don't have like lines on lines on lines going off into eternity. So kind of little, basic little quality of life thing going on. We covered that, we covered that, we covered that, we covered that. Oh, that's useful. Sorry if we're kind of hopping around. So earlier, if we go back to the while loops, or let's set x equal to 0, right? And let's say while x is less than 5, we want to run. And then let's print x. And then there's a special keyword that I want to show you. Break will forcibly exit a loop. Except I'm a liar. Oh, break will also exit a condition. So we need to... I think it's break 2, if I remember correctly. No? Damn, making me a liar. Son of a... This is what you get when you try to teach too many languages at once. No, that's valid. Oh, I used the wrong, wait, no. What? You're saying here? But then this will only increment x when it's greater than 3. And therefore the loop will run forever. So if we set x to, or I'm sorry, yeah, because it won't, x will always be 0 and it'll never increment. That's really weird. That should work. It should stop at 4. Oh, it does stop at 4. Yeah, you're right. Let's do this. Sorry, it's because I don't know how numbers work apparently. There we go. Oh, hold up. There we go. Break took us a little while to get there, but break will exit the current loop. Okay, so in this case, the loop was going to run until we hit 10, or I'm sorry, while we were less than 10, but because we broke when x was greater than 3, in which case when x was 4, it broke out of the loop and the loop ended. So that's really nice if normally you want to go up until some point, but there's some sort of reason that you want to maybe stop early. This also works for for loops. So you can say, really Python, come on. Same thing. Okay, nothing new. Now here's something cool. Who remembers the modulo operator? We got one person. One person? Oh, you guys make me. Oh, 2 people. All right, cool. Can one of you tell us what modulo does? Correct. So let's just reset x to 0. And let's also do this here. There's another keyword called continue. So what we're going to do here, ooh, we don't actually want to do that. That's what we want to do. Okay. In this case, x starts at 0. This loop will continue running while x is less than 10. We're going to print x, and then we're going to increase x by 1. In the case that x divided by 3 doesn't have a remainder, so 3, 6, 9, it will skip that run. And I think that's actually not what we want. Yeah, because that will forever run. Let's do this. Slightly different, but whatever. So we're going to increment x, we're going to print out x, and then if... No, that still isn't what we want. Yeah, you're right. Let's just do a for loop, screw this. There, how about that? There we go. Okay, so each loop is going to count up x. So 0, 1, 2, up through and including 9. But if x is divisible by 3, it's going to skip that one. So continue is useful if there's some reason where you don't want to continue with the remaining logic in the loop, and you just want to move on to the next step in the loop. Okay, does that make sense? Yes, no? Am I putting you guys to sleep? Should we move faster? Or... Nothing? Man, tough crowd.
Or can you just change the condition to for x in range number is 3, whatever. Oh, never mind. So.
Well, we can do,
I'm just thinking there's another way to do that.
Yeah, we could say, basically just keep skipping this if x is greater than 5. Whoops. And then the loop runs all the way up to 9. It just doesn't print anything because the printing is before. We could do, whoops. Oh, hey, that was cool. How'd I do that? We can make that a little more evident if we do something like this, where you can see that it prints out, the loop is still running, but because the continue is here, this gets skipped. Okay. Cool. And what do we cover? So we did that, we did that, we did that, we did that. It's going a lot faster than I anticipated. List comprehensions. I hate list comprehensions. Okay. So I'm actually gonna have to refer to. So we have a list like this, right? Or we can also say, give us a list of a range up to 10. Right? So that's one way to construct a list. But you can also construct a list using a loop. So you can do something like, let's just say I for I in. So this is an example of a list comprehension. Yeah, it's kind of messes with your head a little bit. Are we doing on time? Okay, cool. So this is so basically what this is doing is it's saying we're going to take I and we're going to put it in our list. And then we're going to run a loop where we're setting I to all the values output by range. So we could do something like this. What will our list look like when we run this?
Would it only include 1/3 division point?
No, because division returns floats, so you'll get decimals. Yes. So that's kind of cool because you're basically counting by 0.5. You can also do, and this is a lot less useful, but you can do something like range 10 is 0 through 9, but by adding 1 to I, we're getting 1 through 10. Silly things like that. Could also do. I'm just showing examples because this is kind of hard to get into your head. So again, counting from 0 to 9, but multiplying by 3 and storing that in our list.
Because the range is not a function, it's a code.
It's a function.
It's a function.
Range is a function.
Because the range function will not increase by distance.
You could instead do.
It seems like unnecessary.
Yeah, you could do 0, 10, 0.5. Or actually, in this case, it would actually be more like this. Whoa, what? Cannot be interpreted as an integer. Oh, I guess range only accepts integers. Well,
I just tried it.
yeah, I guess range. Let's take a look real quick. Or Python's not going to tell me type, is it? Of course not. I hate Python sometimes. Oh, jeez. Okay. So in that case, you would want to use a list comprehension because range only likes integers. So if you give it a 0.5, it's going to be like, that's not an integer. What the hell? Okay. And I think.
You do negative for this step?
Oh, you mean like negative I?
Whoa.
Yeah, you could always do negative I. Now this can be any expression. Any expression. You can even do something silly like because 1 is constant, right? 1's not going to change no matter what I is. So things like that. You can also do this with. You can do this with. I think you can do it with sets, or does it do it with dictionaries? I don't know. Let's find out. If I could learn to type, I think after. Oh, whoops. I'm so used to doing lists. Now, what is the type of that? Yeah, so you can do it with sets. You can do it with dictionaries too, but I forget what it looks like. Let's take a look real quick. Where is it? Where is it? Oh, that's cool. Okay, so check this out. I didn't actually know this at all. Oh, this is so cool. Oh no, that'll do a tuple. That won't do a dictionary. But it's still worth showing. Okay, so remember earlier how I showed unpacking where we had like, oh, damn it, I did it again. Oh, screw you. I hate idle so much. Remember how we did this crazy tuple of lists that we had earlier? Right? You can do that with list comprehensions too. So you can say, we can do something like this. Or do we need any sort of separator for that? I don't think so. Nope. Man, Python is strange. Oh, that looks terrible. I should have done. Here, let's do this with a smaller amount of numbers. Let's do 3 and then 3 to 6. So this does every combination of both. So it starts with I being from 0, 0, 1, and 2. And it's going to combine it with each value of j, which is 3, 4, and 5. So 0, 3, 0, 4, 0, 5, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5. Cool little list comprehension things.
That was when j has a range bigger than I.
Then you would have 0, 3, 4, 5, 6. 0, or 1, 3, 4, 5, 6. Whoops. Oh my god, I can't type. There we go. 0, 3, 4, 5, 6, 1, 3, 4, 5, 6, 2, 3, 4, 5, 6. Make sense? Is anyone confused? So that is a thing. Oh, also, you'll notice that this is a tuple. I believe we could turn that into a list too. We have a list of tuples. We could also do a list of lists. It's a list of lists. Big deal. Then there's dictionary comprehension, which is crazy voodoo magic to me. Okay, so is there a clear? There's not a clear. We tried that last time. So then we can do something like, oh man, or we can say I, and then let's just say I minus 1, and then so we have our key, and then we have our value, just like within a dictionary. Oh, that looks terrible. Let's try, let's actually use the example they use in the book. Whoops. Can anyone tell me what this is going to print out? What? Oh, yes, you're right. Sorry, yes, because I can't count. Yes. I was being really dumb. Thank you. Yeah. Because len is a Python built-in. I think we covered it last time when we did collections, tuples, and lists and all that. Len gives you the length of either the list or a string or a tuple or whatever. So in this case, we're counting the length of the string num, and num is one of these values that we're pulling out of y. Does that make sense? Now I want to try something because I'm not entirely sure how this would work. I'm just going to call it blah. Will this give us... So remember earlier how it runs the first loop and then runs it for every value in the second loop, and then runs the second loop, runs it for every value in the second loop, so on and so forth? Having trouble seeing the back still? Is that better? Cool. Whoa, it's tripping out, man. Oh, geez, really? Okay, there we go. Can we, let's just do this. Whoa, no, this. There we go. Wait, what? How, what? No, I want, that's good enough. Let's roll with that. Yeah, that'll just have to work. Because the second loop is running for all instances of the first loop, and each time you're just setting the key to a value, it's just going to use the last value. Yeah. So there's that. So that is list comprehensions, but there is one more kind of list comprehension that allows you to create wait, what? Oh, this is actually a cool example. It's a set comprehension. We did sets earlier, but this is, actually we don't even need to do a set. We can do a list, but let's just do a set. So we can say num for, or let's just say I. For I, let's do this. And you can tack on a condition at the end. So what will this do?
Same as page
Correct. Yep. So other cool list comprehension things, you can tack on conditions. Questions? Alright, now we can do generators. So you get list comprehensions at this point. They're pretty simple. But what if we try to do a tuple? Okay? Remember, tuples are immutable. They cannot be changed once they are created. That's not a tuple. The way that a list comprehension works under the hood is it actually runs the loop and it modifies x each time. What can't you do to a tuple? Correct. So what it instead does is it provides a generator. Whereas with a collection, you have all the values stored, and they just exist, and you can pull them out as you please. A generator produces values one at a time on demand. Okay? So we can say, now that X is a generator, so doing this with a tuple produces a generator instead of producing a collection of some sort. Okay. Now the nice part is that a generator works just like a collection when you're iterating through it. When you are iterating through it. However, you cannot go backwards. I can't go x of 0. Doesn't let you do that. Because the values aren't stored anywhere. They're, again, generated on demand. So if you try to pull out a value at some index as if it was some list or some tuple, it gets unhappy. However, I believe whoops. Oh, well. And that doesn't work because what you can do is if your generator is not out of values, we loop through the entire generator and we used up all the values and it's done. So the generator was empty. But if we try this again, you can still convert the generator to a list, and then it will generate the values for you. But now if we try to do this again, there's nothing left in the generator. It generated all its values, and now it's spent. So it produces each value one at a time, and then it's gone, it's out.
What are the uses for that?
If you have a predictable set of values and you don't want to use up any memory, generator is useful for that because it only produces them on demand. But that's only like really, really high performance stuff. Mostly this is so that when you're starting out, if you happen to see a generator, you don't get confused. There's also some libraries, because the libraries need to support high performance stuff, they'll provide generators instead of collections. I actually don't use generators that much, so I'm sure there's more examples, but I can't think of any off the top.
So once it spits it out, then it's gone.
It's gone. I don't think a generator has... Let's go ahead and produce this generator again. Really, Python? Ah, come on. God, I hate idle. Generators have methods, like I think you can do x.next. Really? Really, really? Really, 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 really?
You do X dot and then it'll give you all the different stuff.
Does it? Because I just tried that. Ow! Ooh, what does that do? Sorry, I'm curious at this point. Wait, so it takes one argument, but it only accepts... Okay, I have no idea what that does. If you're curious, we can figure it out afterwards, but that's like way ahead of whatever we're doing now. So that covers generators. We have 40 minutes left. Why do they put functions in the same? Oh, you know what? That actually makes sense. Okay. Oh, and if we do this quickly enough, we can make a calculator. So
you have the method underbar, next, underbar.
Oh, that's the one.
Instead of the next. Underbar, next, underbar.
Oh, that's right, because it's a built-in.
And then
you need to. Oh, it's a built-in method?
Yeah.
Oh. Whoops. Whoa. Oh, no. That's not what I meant to do at all. There we go. No, stop. God, my keyboard, I hate it. That's funny. Okay, that's good to know. So, just a general note. If you ever see a double underscore, that's kind of a built-in Python method. It's kind of basically like kind of under the hood stuff that you're not supposed to really get too far into. When a loop runs a generator, or when it runs a list, it actually calls this underscore underscore next underscore underscore function. So if we do something like this, I'm actually betting here, I could be wrong. Oh, nope, I'm wrong, never mind. But when you run a generator, it actually calls that function. Oh, that's right, because when you run a for loop, it produces an iterator off of it, because a for loop list is an iterator already. Okay, yeah. But that's just crazy voodoo magic. You don't really need to worry about that. If you see double underscores, you probably want to look up what it is. It's a Python built-in. There's underscore underscore init, underscore underscore name, so on and so forth. But now let's get into functions. Functions are where things start to get useful. And actually let's go ahead and create a new, well, no, let's just do it this way. So functions allow you to take some body of code and summarize it into a single name and reuse it whenever you want. So we can create a function called add, okay? And then functions are signified by using these parentheses, okay? So you'll have some sort of name, and then you'll have parentheses, right? And when you define a function, you put def in front. This means that we are going to create a function that we can use later on. So in this case, we can have a function can take information in. It doesn't have to, but it can take inputs to itself. In this case, we're going to give it two inputs. We're going to give it A and B. And then much like a condition or a loop, use a colon to say, okay, now we're going to define the contents of it. And then functions have a keyword called return. Return ends the function, and whatever is after return is produced as output from the function. It's a little confusing, but let me show you. So we defined a function, add. It takes in two values, and it outputs the sum of those two values. So when we run this function, what's happening kind of behind the scenes is A is getting set to 2, B is getting set to 10. It adds A and B together, and then wherever we call that function, it spits out 12. So we could do something like the function is replaced with whatever the function outputs. Okay? Does that make sense? Is anyone confused? Or are people bored to tears? Alright. Well, if you're bored to tears, then let's get a little faster. So that's kind of basic function stuff, but you can do all sorts of things in functions. So we can say, crap, maybe I should have thought through that a little more. We can do something like is odd, right? And it'll take in one value, and if A mod 2 equals 1, return true, else return false.
What if you use print instead of return?
It'll print it to the screen, but no value will be returned. So let's try that. And let's also use strings since we're going to, oops. Okay. So it prints it immediately. However, if I were to try to do something like this, x is nothing. There was no output from the function. The output is none, technically. So, yeah. You can totally do that.
Normal in the beginning. I'll still take the number, but it wasn't being stored.
Yeah, you need to be very careful. And it's especially confusing with Python because you can just enter a value and it'll print it to the screen. Like that's terrible for learning. Because printing is not the same as assignment. They are two completely separate things. It's just that Python kind of blurs the line to make it quote unquote easier. Fuck you, Python. So yeah, that's kind of functions in a nutshell. So what I would like to do now is let's see if we have 30 minutes left. Do people want to try to make a calculator? So there's one function that you need to know about. It's called input. Okay. And input, we covered this a while ago, but refresher. So input will print some text to the screen, and then whatever the user enters into the terminal, or command line, or shell, whatever you want to call it, and hits enter, whatever value they typed will be stored, will basically be the output of the function called input. So we can say, give me a number. Let's say I give it 5. X is now 5. Of course, it does it as a string because it doesn't know what you're going to put in, so it just assumes everything is a string. So what we probably want to do is something more like this. And now X is actually an integer because we forced it to be an integer. So now, let's 30 minutes. We can probably accomplish 1 or 2 operations. We won't be able to make an entire calculator, but let's go for it. So I'm going to create a new file. Feel free to follow along. You don't have to. Let me go ahead because we're going to do this together, and let me go ahead and create a new thing for the recording. Yeah, that'll work. Beautiful. Oh, God. Come on. Really? There we go. Beautiful. Is that actually... Oh, it's only capturing the inner window.
Sorry, Brian.
Yeah.
You should also show,
Did I skip something?
for conditions, you should show and or.
Ooh, thank you. Thank you, thank you, thank you. Sorry, guys. That's really important. Thank you, thank you, thank you. So remember earlier conditions, we can say x is greater than, or let's set x equal to 10. If x is greater than 10, print x is greater than 10. Whoops. Right, pretty straightforward stuff. Oh, x is equal to 10, so it's not gonna, let's do this. Right. You can combine conditions. So we could say x greater than 5 and true. Right? So Python supports the keywords and or. If you do something like this, though, actually, let's do something like this. So x is currently 10. Will this print? Why will this print? Not Bernard. Anyone?
Or is any of the comparisons, if they're true, then it's true.
Correct. if any of the expressions on either side of the or are true, the whole thing will evaluate to true. You can also combine. So we can do something like if x greater than 10, or let's say and x is even. This is another way to say something is even. Or true equals false, right? Because that first expression is true, even though it's a combination of true expressions. Ooh, am I dumb? Hold up. Oh, because x is 10. Damn it, I keep doing that. Let's just do this. There we go. Like, true is obviously not equivalent to false. But x is greater than or equal to 10, and x is even. So this block evaluates to true. And then because we have an or here, if this one's true, it doesn't matter what's after that. Okay? And you can use parentheses to group things. Kind of like your pre-algebra math, if anyone remembers that. Questions? Thank you, Bernard. Appreciate that. All right, cool. Where'd it go? Whoa, it's tripping out. Okay, cool. So now let's try to make a calculator. So someone explained to me, we have the ability to do input. We have the ability to do math. We have functions. Debating. So I wonder if I want to try to do design by collaboration or just kind of guide. What do you guys want to do? Do you want to try to figure it out together, or do you just want to kind of be told how it works? Or maybe I can show one operation and then you can try to do a second one together, or what do you guys prefer?
Yeah.
You want to do collaboration? Okay. So we have input, we have functions, and we have all sorts of conditions and stuff. All right. So how might we try to make a calculator? So when think about if you have a calculator in front of you and you want to do some operation, you could, but in this case, we're just going to do one operation at a time. So
you get the user to input what they want to do, like plus, minus.
Okay. I'm going to do this to make it pretty.
So you can literally tell them like plus, minus.
Okay.
Divide and multiply. We'll do those four, I guess.
Sure.
We can do them one.
Let's just start with add for now, because it's going to get really long really fast. Okay. Or let's actually call it operator, because X might get confusing. Okay. So we ask for an operator, then we get an operator back. Okay. So our operator is given to us as a string. Okay, it's given to us as text. So what do we want to do next?
You want to get, no, there's no catch. So next you want to input two numbers.
Okay.
First number.
And then someone else needs to do the next one.
Can you explain them to time? Whether you want to add, subtract, divide, or multiply.
Correct. So what would that look like?
So operator equals
Is equivalent to?
plus.
Do we want to just print the output? And then what do we want to print? Okay.
Okay.
Pretty much. All right, let's try this. Oh, did it run? That does not look. Oh, thank you. Yeah, it's fine.
You always have to.
I hate everything forever. Let's. Do I not have a Python folder? It's terrible. Okay. So let's. Really?
Oh, you need to convert.
What's that?
The first number and second number are string.
Correct.
And we need numbers.
Yes. So let's go ahead and just go ahead and. So what do you want me to enter? Let's see. Let's just see what happens with this plus. Okay. Two. 25.
Yay!
Now, why did that? He mentioned it, but someone else explained. Why did that? And neither of you two. So why did that happen?
So the last doing user.
Yes. And what is it currently? Yep. Now, do we actually want it to be an integer? Because what type of number is an integer? Yes. Do we want to only allow whole numbers? Lazy. Lazy. What's another data type we can use? Does anyone remember? Floats. Okay, do you want to try this again? Do I keep, oh, damn it, you know what, let's just do this. Sorry, I need to make sure the recording works for, oh jeez, it's tripping out. There we go. What, are they really blocking each other? Oh, really? Piece of crap.
You know.
Yeah, I'm a little hangry. Well, we'll just have to get I'll just have to keep switching back and forth. So yeah, we'll convert it to a float, and then we'll run it. So let's give it a plus, let's give it a 5, let's give it a 25. Cool. Good.
Check if your operator is valid operator.
Yes. How might we do that?
What about make
Good.
Oh,
So we need like split out of the scope.
Yeah, so
Regular expression.
so think about well now if you start be careful now. I love me some regular expressions. My job was regular expressions for a year, basically. Oh, I love it. Let's not go there though. That's really confusing. So think about it in English, right? We enter a first operator. Okay, so we as a calculator receive a first operator, and then what is your thought?
validate.
Okay, but what is your thought process for making sure that it's valid?
Is it something I read?
Yes. Okay, so you kind of mentioned one way to do that. So how would you, I'm kind of getting you through the practice of software design.
I get it.
Yeah, go for it.
So I was just gonna make a list, plus, minus, divide, and multiply.
Ooh, which reminds me, because I forgot to show you guys something. So, something like this, is that what you're saying? Okay, so we have a list of operators that we support. Now what?
Or if something's not, you can use like an else,
Yes.
pick it up.
Uh-huh. You could do that. So there's actually two ways we could do this. We could do is we could say if it's a plus, elif operator is a minus, right? So on and so forth. Else, not a valid operator, right? Something like that. So that's one way of doing it. Another way that we could do it is we do the work kind of up front, and we say if operator in operator list, or rather not in, we go ahead and just print, and then we exit. I don't think return would actually work, but whatever. Or rather, maybe, whoa, typing, something like that. So that is one way of doing it. Okay, so let's run this and test.
Isn't that great?
I don't know how it's treating this. I don't know if return's actually valid, so let's try it out. Because I never use, return outside function, so yeah, let's try break. I don't know if break will actually work. Nope, because break needs to be in a loop. I guess we're gonna get way ahead for a second. Oh, here we go. Or we could just conditions inside conditions. This is not how I would actually recommend to do it, but with the knowledge that you have right now, this is the best way. Well, except for maybe doing a bunch of if-elses, or else-ifs, and then having an else for an invalid operator. That's actually what I would do, but this works too. So let's try running this. Let's give it a plus, let's give it a 5, let's give it a 25, bam. So far so good. If we run it again, let's give it an F. I wonder why. Might be hangry. Questions? Is anyone confused?
Why don't you just,
What's up?
instead of printing out not a valid operator, why don't you just say, give me a real operator? And then make them input.
Okay.
And then make it input. Operator equals input.
Okay. Let's go ahead and run that. Do you want to give it a plus this time? Correct. Why not? Someone who's not Bernard, tell me why that didn't work.
Else.
Kind of true, yeah.
Yeah, because that's just one if statement, the whole thing.
Correct.
It's just going to go to the bottom, and there's nothing in the bottom.
Correct.
After the statement.
Yep.
So it's the moment we need to use the while or, loop.
Yes. So let's, so we can do something like this. Oops. actually make this a little bit bigger. Does this make sense? Does anyone not understand what we're doing or why we're doing it? Cool.
Coffee must be in, not. On.
You sure? Correct.
I think you have to explain why the operator equals
Yes.
exclamation.
So if we try to access a value before we've defined it, Python's going to be like, what the hell are you talking about? So by setting it to a blank string at first, it doesn't complain. If we do this, and this tries to run, it's going to go, well, operator, not an operator list. Wait a second. I know what operator list is. What's operator? I have no idea. You've never defined anything's operator. There's no function called operator. There's no variable called operator. I don't know what that is, and it's going to freak out. So if we put this, actually we could do even better. We could just do that. Operator exists. It doesn't have a value, but it exists. And then because none is not in the operator list, that loop's going to run. Does that make sense? It's okay to say no. Alright. So what should we give it? Q. A. What else should we give it? Pi? Well played. Let's give it a plus, and then it continues. Because it is no longer true that the operator is not in the operator list. The operator is a plus, plus is in the operator list, so the loop ceases to run. Is anyone confused? So far so good? Cool.
So what happens when you put it alphabet for the first number? Enter first number. Put it.
It's a good question. Let's try it. Let's give it an A and a B. Ooh! So, this happened because we instantly tried to convert the input to a float. Okay? If you try to convert the letter A to a number, that doesn't make any sort of sense. Python's like, what are you trying to do? So, and I had an idea in my head. We could do something similar. Oh man, my memory. It's going to be slightly advanced stuff, but let's see if I can remember how the hell to do this. I think that works? No, because that gives an exception, right? Yeah, I don't think this will work, but I'm going to try it. Let's try it. Let's see what happens. Ooh, what? Oh yeah. So we didn't even need to give it input because it tried to convert none to a float. Something like that. Actually, exception handling was next, wasn't it? Well, we have 10 minutes left. And we still had more stuff we needed to do with functions. Yeah, we probably shouldn't.
Yeah, let's do that next time.
Yeah, let's do that next time.
If we want to place that.
Yeah. We'll pretend that our users are intelligent people who won't enter. Yeah. Now, in real life, you should never make an assumption like that, but for the purposes of our class, you're not going to break our calculator, right, guys? Right? Why would you ever do that? So, just for the stream, or not stream, for the recording, looks like this right now. We're going to continue more next week. But if we run this guy, we give it a plus, we give it an 5, and we give it a 7, ta-da. Does anyone want to explain how we might do the rest of it for the remaining 3 operators? Yep. How do I type that in Python though? Yes. And then what?
Do you also feel like I would operator equal operator list bracket 2 or 1? That would be equivalent to recommend.
You could. Yes. Let's actually do it for this one. It is less clear though. So I don't know, better is debatable. Clarity is king. What's that? Ooh! How would we do that?
Well, it'll take a lot of time.
No, it wouldn't. No, it wouldn't.
An operator list. Plus, literally FLP alias mystery.
We can do better.
You can make another list of different.
We can do better. You could do that, but we can do better. I might be in the dick by withholding knowledge. Oh, actually no, because you can't store operators. Can you?
Trying to use countdown.
Kind of, yeah. So never mind, we can't do better. I'm an idiot. I mean, you could if you got into some crazy advanced shit, but we're not there yet. Advanced stuff.
Where's that?
Bringing our time.
But we're not there yet. So yeah, you could do this, but I would personally recommend not doing it because it's not as clear. Because then you have to keep going back and forth, and it's a giant pain. What I was hoping we could do is something like this. And there's a way to do something like that, but it's messy, and we haven't learned how to do that yet. So, because then you could just say, you could just do something like, even though that looks kind of gross too. Maybe it is better to do it with the LF, but you get the idea. So this too will work as well. So if we save, we do this guy, run, we do that, same thing. So yeah, that's another valid way to do it. I personally recommend against it because it is not as clear, but it does work. And then we can always do. Sorry? Okay. Oops.
Is there a way to run like code that's not And instead of running it from the beginning, you like select code and run.
So that's effectively a function. So what you could do is, let me just test this real quick. Cool. You could do, something like, damn it. So what we did was we defined a get inputs function. We took all the logic to grab inputs and we put them as the function definition. And then we call the function. And then I'm going to call the function a second time. You can call it as many times as you want. Now in this case, the second time it runs, it won't actually do anything. It'll collect inputs and then it'll end because there's no logic after that. So it wouldn't be useful. We could do something like oh, that gets really gross. Let's actually not do that. I don't know. We can. Yeah, let's do that. It would be. We're almost out of time, but let's just roll with it. Oh crap. Whatever. I mean, it doesn't really matter. Yeah, let's just keep the same names. Let's actually make this huge. It is a little weird.
I thought it was weird.
It is.
Conclusion.
It's really sneaky.
There we go. So we have a function called getInputs. We're actually going to return 3 values. And then we have a function called doCalculations. And when it takes in 3 values, okay, so we kind of separated the 2 blocks of logic. And we're going to get inputs and output those 3 values. And then we're going to feed them into doCalculations, and we're just going to do that twice. Okay? So let's go ahead and save this. Let's bring idle up. Let's run it. So it'll basically do the whole thing twice. Huh? Oh. So I got unlucky because I chose multiply. So why did this fail? If you look at our code really quick. So what's happening is it's like I don't know what operator list is. That's what this error means, okay? So if we look at our code,
On your block. That's how we're referencing.
correct. We defined operator list here. And because we defined it inside this function, it only exists while that function is running. When the function finishes running, that value disappears. So we could go ahead and define it in what's called the global scope. We'll cover more of this next week when we get into functions more deeply. But this fixes it because now operator list is available to all of the functions that run. Because it's in the global namespace. It's a little more advanced than what we covered today, but that fixes it. So now we do plus 5, 3, and then we can do times 6, 2. And because we grabbed inputs and did calculations twice, it does that twice. So you can run those blocks of code however many times you want. So does that answer your question? Oh, really?
Like, for example, at the bottom of this, you want to put input your name. So you have your calculator and then your name. But I want to test the name part to make sure that's right instead of running the whole thing all the way.
Oh.
Is that possible?
That is, you would want to use Python actually has a testing framework built into it. And you would want to use that. You would basically you would import this file as a module, and you would pull out that print name function and then run a test against it. But that's much later.
Really keep running the same thing.
So that's why generally you have kind of a library of all of your functions, and then you call them at will. And then it's called unit testing when you have an individual function and you want to test that function works. And if you have things kind of organized in libraries, then you can do unit tests as you please, and then you can have your main program flow separate. So does that?
Yeah.
So yeah. Any questions before we adjourn? Because we're totally a little over time.
Can you post that up, code
Yes,
for us?
I'll do that. And I'll also post a video. But the code would be more useful if you want to check it. So yeah. Any other questions? Or is everyone good? Cool. Well, thank you, friends.